Right, hello, welcome to another video. This time we're going to be differentiating this big function here. Well, we're going to be changing the form and making it much easier to differentiate. So let's just say f function, and we're looking to, in fact, no, let's not do that. Let's just write this d to the dx of this function here. So first thing we want to do is we want to tidy up the denominator because having a root x on the bottom makes this whole thing quite difficult to integrate. So what can we do? We can multiply the top and the bottom by the by root x plus 1 in order to eliminate the root. But whatever do we do to the bottom, we must also do to the top. So we multiply the top by root x plus 1 and then the bottom by root x plus 1. So the denominator just becomes x minus 1. The top, we have to multiply every term by root x and every term by 1. So we have x root x minus 3x plus 2 root x plus x minus 3 root x plus 2. Now, if we bring all the root x terms together, then we just organise this the numerator. We get root x, and we have an x term here. We have a minus 3. We have a plus 2, and that leaves us with root x minus 1. Now, it's convenient because that's exactly the term of our denominator. So, with the first bit we can cancel, and we're just left with root x. Now, what about what's left? What's left is minus 3x plus x and plus 2, all over x minus 1. Now, minus 3x plus x, that gives us minus 2x, and we're left with plus 2. Can we bring x minus 1 out as a common factor? Well, yes, because if we bring out minus 2 as a common factor, we get x minus 1. And what can we do with that? Well, we can divide through again. X minus 1, x minus 1. And what we're left with is root x minus 2. And this is equivalent to our previous function. It's equivalent to all of this. This whole thing is equal to root x minus 2. Now we need to differentiate this. Any constant just becomes 0. Root x, we convert this to x to the power of a half. And differentiating this gives us 1 over 2 x to the minus 1 over 2. Or 1 over 2 root x. And this is our answer. I thought this was quite a fun little problem to do, and I sent the solution over to my colleague who found it quite helpful, I think. So that's good. And yeah, it's a nice little approach. It's a nice little problem with this approach, and a lot of these kind of questions, it's totally intentional that you can bring the x minus 1 as a common factor for the root x term and for the minus 2. So when you are attempting a question like this, just look out for these little, quote, coincidences, because they're not really coincidences. They're absolutely intentional. Right, thank you very much for watching, and I'll see you for my next video. Bye!